Alright, this is my CSC 380 Dance Battle Competition Artificial Intelligence. Start by showing that it's working. I used just string files that you can comment out for the test cases here. So we'll run test case 1. And there we go. We got move busted is 1-1. Max is the winner, which is what we expect. For test case 2, here we have moves busted. This one, min is the winner, and obviously shows the moves that we got to get there. And lastly, I don't have alphabetic pruning because I'm undergraduate, but obviously my test case 3 runs out of memory space, so we'll get that error, but for now we'll just move on. We'll go through the main. So we just pretty much have, like I said, the string files here. You can comment in and out depending on which test case to run. Use a buffered reader, read each line, have an array list of strings. Obviously the first string is going to be the number of moves, so we get that. Second is the number of turns taken, so we get that from parsing. Then we go through, and if we have any more strings in the array, we are obviously going to go ahead and get those, build the game state, the initial state, and then from there we make the root node. From the root node, once we create the root node, the whole tree is created. So from there we create a min-max object. We call the min-max algorithm on the root node to analyze the tree, and then we get the solution, and we print out the solution to the screen and print out the winner. Moving on to node, we have okay, there's test case 3 has crapped out, overhead limit exceeded, out of memory. So anyways, back to node. We have an array list of children, number of nodes, game state obviously, which is the two-dimensional Boolean array, last move. Each node has keeps track of whose turn it is, keeps track of its utility, has a dance move object that's just two integers smacked together. We have a constructor for the root here. Takes the number of moves that are possible, takes the game state, which would be blank if no moves have been made. Otherwise, if we built it, it's putting it in there. It's got a last move. If it's -1, there's been no moves yet. And then turns taken so far, and builds a node, calls a successor function. Similarly with the node constructor for children, it gets past the parent reference. It's got a Boolean array, two-dimensional Boolean array, just like the other one. Whose turn it is, for Boolean T is whose turn it is, as a last move. And dance move object, that also calls a successor function to create the tree also. There's the inner dance move object. Like I said, it's just two integers. Successor function basically just goes ahead and builds the entire tree. So every time a node is constructed, the successor function is called, and then any children that it can possibly have are created. So obviously if it's terminal, then no children are created there. But that's keeping track of the game state, obviously. Then we just have a bunch of accessor and modifier methods and stuff like that. Has children method. And lastly here we have the min-max. So if we've made the root node, then we have the whole tree, but once we call the minimax algorithm here and we pass it the root, that's going to go through recursively right here. So for each children, it calls the minimax algorithm to do that recursive call. If it's a terminal node, then we are setting the utility in that node, depending on whose turn it is. And then obviously as those recursive calls return, we're going to need to bump that that utility value up. So that's what we're doing here. If it's max's turn, we're going to maximize. If it's min's turn, we're going to minimize. And then I just have a get solution function, which basically goes through after the utilities are all applied and gathers a solution. If max can win, it's looking for that, obviously. And that's about it. Thank you.